In these two examples, we are going to begin to do some integrals or antiderivatives of problems that originally were chain rule problems when we did the derivative. So there's a look to this that we want to recognize of when are we going to use U substitution. And if I were to do a derivative of this, it kind of has this chain rule feel. I have an inside piece and an outside piece. I have an inside piece and an outside piece. So that's one of the first things that we want to look at is what is the inside piece? Because that's what I'm going to replace. I'm going to sub it out. I'm going to sub out the inside piece with U, right? So if I have that, my U is going to be my inside, so x squared plus 1. What I'm going to do is the derivative of that, which is going to be 2x dx. So normally I'm going to start by kind of manipulating some of this a little bit. And so on this, I'm going to take this piece, x squared plus 1 to the fourth, and I'm going to mix the 2x with the dx because as I did this derivative, I saw I have a 2x dx, and so I can perfectly sub out that piece with du. So what I'm also going to do is I'm going to take this inside, which was my u, and I'm going to replace x squared plus 1 with just u. So we're really looking to do the antiderivative of u to the fourth, and this gets subbed out with du. Right? So I'll add my power, divide by my power. So u to the fifth divided by 5 plus our c, since we have an indefinite integral. We don't have any values attached to it. We don't have any bounds. And so then my last thing is kind of pulling it back to the original. This is what I replaced u with. And so I'll rewrite that as I'm going to make this a 1/5. And then x squared plus 1, x squared plus 1 to the fifth power plus c. All right, so there's situation number one. Situation number two is that definitely anytime we have a square root type of a problem, we would have had to do a chain rule. We had an inside and we had an outside. This is our inside. So that's what our u is going to be. So I'm going to have just a 1 minus 4x to the third. And before I go any further, I'm going to do some manipulation of this. So I'm going to take the 2 out of the integral. I'm going to make the fraction. I'm going to get rid of the fraction. I'm going to pull that x squared off and mix it with the dx. And this piece right here, I'm going to make it more antiderivative friendly, just like we would make it derivative friendly. So right now it's a 1/2 power that I'm going to bring up. 1 minus 4x cubed to the negative 1/2. And then that x squared is going to mix with my dx and look like that. So what ends up happening is if this is a u substitution, and I take this u that I believe is going to be my u because it's the inside, and if I do the derivative of it, du equals a negative 12x squared dx. And what I'm looking for to know that u substitution was a thing, was an option, is that x squared dx I perfectly have right here. And so I can finish and complete my substitution where I can isolate the x squared dx. I'll divide that 12 over to the other side on this, so that would make it a negative 1/12. du equals x squared dx. And then now I can take my x squared dx, replace it with a negative 1/12 du. The du I'll leave here, but the negative 1/12 I'll take out like we did with the 2. So it'll be a 2 times a negative 1/12. And then integral of this is getting replaced with u. So it's going to be a u to the negative 1/2. And then x squared dx is part of my substitution with du. And the negative 1/12 I took out. So antiderivative of this, we're going to add our power, divide by a power. We're going to simplify this at the same time. So the 2 and the 12 can become a negative 1/6. And then we'll add our power. So we add 1 to a negative 1/2, makes it positive 1/2. We would divide by that power, just like we did here. We added a power, divided by the power. But instead of dividing by 1/2, let's multiply by its reciprocal. And let's see. So that simplifies out to negative 1/3. And then instead of u, we would have our 1 minus x 4x to the third and to the 1/2 power plus c. So this is absolutely an okay answer. Sometimes our original problem, we got to go back to the same format as the original. The original had a radical in it, not a 1/2 power. So this might be fine, or we may be writing this as a negative 1/3 square root of 1 minus 4x to the third plus c. All right, so there's our 1/2 power. So it just kind of depends on, are they okay? Whoever's accepting this answer, are they okay with this version of it, or should we pull it back to the original? And that was a couple problems involving use substitution.